Hey y'all, thought I'd do a video on how to solve quadratics via factoring. So I'm going to work out several of the example problems that you can find in the notebook on this topic, just to give you a step-by-step guide on how to do these, because not all problems need to be worked the same way. For instance, let's start with this first one here. X squared plus 9x equals 0. So, to do this problem and solve via factoring, first thing I want to do is I want to factor out anything that is in common with the two things on the left. You want to make sure that whenever you're solving via factoring, everything is on the same side of the equal sign except for 0. 0 obviously wants to be on the opposite side. It doesn't matter if you have everything on the left or the right side of the equal sign, just make sure that they're all on the same side. In this case, both these are already on the left side, so we're fine. In each of these, we see x. So x is going to be the piece that they have in common. Now, when I factor an x out, to get x squared, you have to do x times x. So I have to have an x here. If I take an x away from 9, there's no x's left. So that leaves me just 9. So I have x and times x plus 9 equals 0. Next, I want to set both x equals 0 and x plus 9 equal to 0. Well, x equals 0 is already solved, so 0 is one of my solutions. X plus 9 equals 0, that isn't solved. X is not by itself. So what I have to do is I have to subtract 9 from both sides, giving me x equals negative 9. So my solutions are x equals negative 9, comma 0. And that's it. That's all she wrote. Now, obviously, it's not always that easy. Sometimes I have to pull out more than one thing, and sometimes I have to be a little creative with how I do things. For instance, in the one immediately to its right, 4x squared minus 8x equals 0. Once again, both of these have an x, so I can pull an x out of each, but both of them are divisible by 4, so I can pull a 4 out. Now, if I pull out 4x from each of these, from 4x squared to 4x, that means there's x left. This was a minus sign here, so this needs to be a minus sign here. The only reason this would change to a plus is if both of these were negative and I pulled a negative out here. Next, if I pull an x out of 8x, that leaves me with no x's. And 4 divides into 8 2 times. So I'm going to write 2. 4x equals 0. X minus 2 equals 0. Divide both sides by 4. You get x equals 0. Because anything that divides or multiplies against 0 is always 0. The only time you get no solution is when you divide by 0. Keep that in mind. Over here, add 2. You get x equals 2. So my solution set would be 0, comma 2. And put your little squiggly brackets. That's what I call them, squiggly brackets. Now, keep in mind, it's for work that I want to see. Step 1. Step 2 at a minimum, and then get to your step 3. You don't need to show me this. I would really like to see this step here where you set both of these equal 0. So in fact, let's go ahead and put a check mark by both of these. I want to see all of these steps, okay? Now, there are a few other problems I do want to go through and explain a little bit on how we know to do this. For instance, and in fact, on some of these, I may go through and actually show you a different way to go about factoring some of this than what has already been shown to you possibly. Now, if we look at, let's say x squared minus 4, the very next one, equals 0. So, what do I do here? Well, if you read through the notes carefully, which hopefully you did, it was set up. You will have seen that we got x plus. That's how we did the notes. And then we listed out everything that multiplies to give me -4. So like 1 times -4, 2 times -2, and all that. So now you also want to keep in mind that when you do this, you could put the negative on the other number, and that's fine. Sometimes you need to realize that these can interchange. For this one, we want to consider, since there is no middle term, and by that I mean that what would normally have a number next to regular x is 0. That's why there is nothing there. That's why instead we write it like this, because there is no x value. So for this one, we want to make sure we choose a pair that cancel each other out when I add them together. Well, 1 plus -4 is -3. And if I do -1 plus 4, it gives me +3. So that can't be it. So hopefully it's this one, or else I've forgotten something. Well, 2 plus -2 is 0. So x plus 2 and x plus -2, or in other words, x plus 2 times x minus 2. Set both equal 0. X equals -2. X equals +2. So our solution set is -2. I don't know why I started writing 0. 2. So -2, 2. There you go. Now, as I said, not every problem is this easy. Take, for instance, number 5 there. X squared. Now, let me just go ahead and rewrite this. X squared minus 10x plus 21 equals 0. Now, if you sit there and you try to think about how to do this, you might have a little bit of trouble. Another way you can do this is factoring via x method, you might remember. Now, using the x method, this is what you got to do. Remember, all quadratics are written in the form ax squared plus bx plus c equals 0. Okay? This is important. If you're doing x method, in the top, you do a times c is what you're looking for. And in the bottom, you're looking for b. So, what you'll do here is, our a value here is 1. Our b value here is -10. Our c value is 21. In the top here, 1 times 21 equals 21. In the bottom, I'm going to put -10. The two numbers that are going to go here must multiply to give me this. The two numbers here must add to give me what's down here. So add, multiply. There we go. So, to figure this out, take 21, list out your factors. 121, 3 and 7, and that's it. That's all of them. Well, 1 times 21 gives me positive 21, but 1 plus 21 gives me negative. Gives me 22. 22, so not -10. If I make them both negative, then it just gives me -22, and if I only make one of them negative, that gives me a -21, which is not what I want. I want positive 21. So, instead, it's got to be 3 and 7. So if I use positive 3 and positive 7, 3 times 7 gives me positive 21, but 3 plus 7 gives me positive 10. I want -10. So instead of using positive 3 and positive 7, you want to use negative 3 and negative 7. And do x minus 3 times x minus 7. Solve. X minus 3 equals 0. X minus 7 equals 0. X equals 3 by adding 3 to both sides. X equals positive 7 by adding 7 to both sides. So our solution set is 3, 7. And that's it. That's how you do this. Now, do you have to do it this way? No. You can keep doing it this way here. Nothing says you have to do it this way. There are multiple ways to solve a quadratic function. In fact, if you want to use the calculator, you can. Just keep in mind, read the instructions on the assignment. If it says to do it a specific way, then you got to do it that way. On the assignments, not necessarily the tests and quizzes. Tests and quizzes, it's up to you how you do it. But on the assignment, if I say, factor these by hand, I want to see this. I don't want to see you using a calculator. All right? Only time you should be using a calculator is to double check your multiplication and addition. All right. I'll do one more. Let's do one on the next page. So if you're looking at the notebook, we're going to do problem 14 is a good one. So we'll do problem 14. Problem 14 says x squared plus 11x plus 29 equals x plus 4. Now, this is a case where not everything is on the same side. So I gotta move stuff around. So for this one, x, I'm gonna move left, and I'm also going to subtract 4 from 29. So subtract x from 11x, subtract 4 from 29. Now you can do this in two separate steps. I'm going to just do it in one step for ease. You know, nobody says you can't do a few steps at the same time. Now, there are only a couple of cases where, all right, let's not do both these at once. Like addition, adding something to both sides, and then also clearing out fractions. So multiplying both sides or dividing by something on both sides. Probably shouldn't do those at the same time. But if you're just doing addition, subtraction to each side, or multiplication, division on each side, if you're used to it, you can usually get by with doing multiple things at once. Just be careful and try to get 2 lost. Okay, so after that, it becomes a simple matter of factoring. If you sit and stare at this one a little bit, you can probably figure it out. I'm going to do X method again. So my A value is 1, my B value is 10, my C value is positive 25. So A times C, so 1 times 25 is 25, and B is 10. Two numbers that multiply give me 25, but add to give me 10. Well, that's 1 and 25, and 5 and 5. Again, 1 and 25 aren't going to work. 5 and 5, though, they do add to give me 10. And I want a positive 10 and a positive 25, so they're both going to be positive here. So that means this would be x plus 5 times x plus 5. Now, notice this is the same. Because both of these are the same, that means when I set them both equal to 0, they're going to give me the same answer. Y'all, mathematicians are lazy. You need to be lazy about this. There is no sense in setting up these two equations and solving them both, because they are both going to give you x equals negative 5, and that's your solution set. Don't waste time doing extra work. Save your energy for the problems that need more brain power. Like, for instance, 16. I'm going to do 16 as well because I thought this one was going to be a little bit tougher, I'm going to be honest. So 16, this one is tougher. Spent a couple moments looking at it there. Now, with 16 here, this one is a little bit tougher. Still, I want to move this stuff to the left. So I'm going to subtract 2 from 98. I'm going to add 3x to 41x. That's going to give me 4x squared plus 44x plus 96 equals 0. All right? Now, for this one, you could do it one of two ways. Either A, factor 4 out, give you x squared. 4 divides into 44 11 times. 4 divides into 96 24 times. And then do it the same way we were doing before, or you could do X method. It doesn't matter how you do this. For this one, if I go ahead and set this up as my x plus, and for those of you wondering, it's like, well, is one of these going to be a minus perhaps? No, both these are going to end up being plus. I know this because this is addition and this is addition. When the middle is addition, both are going to be plus. If the middle, if this here is subtracting, that means at least one of them is going to be negative, all right? Or one of them will be negative and the other one will have to be positive. If this is positive though and this is negative here, then they're both going to have to be negative. So a few ways that you can realize really quickly what's going to happen. Now, for this one, got to list out our factors of 24. 1 in 24, 2, 12, 6, 12. 3 goes into 24 8 times. There we go. 4 goes into it 7 times. Wait, 4 goes into it 6 times. Excuse me. I goofed up. And then we want to find two numbers I had to give me 11. 1 and 24, it makes 25. No. 2 and 12 make 14. No. 3 and 8 make 11. Oh, there we go. So, that gives us 4 times x plus 3 and times 8 x plus 8. Now, if you said 4 equals 0, well, that's not true. So, you don't need to bother with that. Now, setting x plus 3 equals 0 and x plus 8 equals 0, we can solve those for x. X equals negative 3. Subtract 3 both sides. X equals negative 8. Subtract 8 from both sides. So you get x equals negative 8, negative 3. Now, traditionally, you want to write smallest to largest, left to right. However, if you all goof up and write biggest to smallest, I'm not going to penalize you for it because it's a simple mistake and you obviously know how to solve, so don't sweat it. Now, let's assume that you forgot that you didn't realize that you couldn't factor a 4 out, and instead you tried doing X method. All right? Now, if you do X method, here, if I use the original, A is 4, B is 44, and C equals 96. Now, this one's going to be a little difficult because that's going to give us a very large number. And we got a pretty big number down here. So, bust out the handy dandy calculator, people. So, 4 times 96 gives us 384. All right. Now, I'm going to admit, this is the longer way to do it on this problem. I would not do this without factoring out the 4 traditionally. But let's assume that you didn't realize it. Because, honestly, you're not going to realize it all the time. So, sometimes you got to brute force it. And this is one of those cases. So, for this one, we would have to figure out something that's going to add to 44, but multiply, give me 384. Tip. Since this number is, 44 is a fairly big number. I'll admit that. But it's not the biggest thing it could possibly be. Why do I say that? Because if I do 1 and 384, well, we know that two numbers should be positive here. But because of this, guys, 1 and plus 384 is 385. 385 is a lot bigger than 44. So I'm not looking for two numbers that are super far apart. I'm also not looking for two numbers that are super close together, because if I use two numbers that are too close together, they're going to give me too small of a number. If I use numbers that are too far apart, they're going to give me too big of a number. So you kind of have to play with it a little bit and find something that's going to work just right. Gotcha. So instead, start playing around with it. Don't go in order. Skip around a little bit. Test numbers out. It's even, so I'm going to try dividing 384 by some even numbers. Let's try dividing it by 8. So 8 and 48. Okay, well 8 plus 48 gives me 56. That's not far off from 44. So maybe it's an odd number instead. So I tried 9 here. That didn't work. Divide by 10. That didn't work, but it's getting me pretty close. How about 11? No. 12? Okay, 12 worked evenly. 12 plus 32 gives me 44. There we go. Now keep in mind, what I'm about to do next only occurs when A is not 1. A is 4 here. And because I'm working with this, what I'm about to do next is the only reason I do it, okay? Now, sometimes you're going to get to problems where you can't factor anything out to get something nice like this. On the problems where you can't, you're going to do this next trick here, okay? So, for this, what we do is we take x plus 12 and x plus 32. Now, for this problem, because, again, I can't stress this enough, because A was not 1, this is going off of the original problem as if I didn't factor anything out. Because A was 4, I have to take 12 and 32 and divide it by 4. If 4 does not divide into 12 or 32 evenly, you take this number on the bottom and you bring it up in front of the x, and it'll go right here. This is what we call the bottoms up method. It only works if this number does not divide evenly. Luckily for us, 12 is divisible by 4 evenly, so 3 times. And 4 goes in 32 8 times. Notice I'm back where I was before. X plus 3 equals 0, x plus 8 equals 0, and we already know how this show ends, with x equals negative 8 and x equals negative 3. This is just another way to do it. This method is not the best. It is not a lot of fun, but it can be done. There will be problems where you cannot factor anything out, and you're gonna have to brute force your way through. All right? Make sure you check out the notebook for other videos on this topic, guys, because trust me, these videos will be much help for the test and everything. All right? Take care of yourselves.